Hi, I'm Marc, product specialist for tequipment.net, and today we're here to talk about what is soldering, why do we solder, and how do we solder. Soldering is creating a metallic bond between two or more pieces of metal. As we see on the printed circuit board, we have wires soldered to the printed circuit board. And the metallic bond creates a electrically conductive path so that the electronics will work properly. So the reason why we solder is to create the electrically conductive path so that all the electronic equipment that we have will work as it was designed. Basically, what it is required in soldering is heat, which is created by the soldering iron. You need your metals to be soldered, and you need solder. So as you apply heat from the soldering iron to the pieces that are to be soldered and elevate the temperature to about 500 degrees, the solder will melt and cause a metallic bond between all the metal pieces. How we solder is through the use of soldering irons or a heat source. You have a variety of different soldering irons, from the simple iron that plugs directly into the wall to the units with power supplies. The power supplies will allow better performance, greater functionality. The key to soldering is recovering the heat that is lost during the soldering process. Heat will go from hot to cold, so even though the soldering iron is not being used, you're still losing heat to the atmosphere. And when you touch metal, you lose more heat. The key to soldering is recovering that heat and keeping the heat at a stable level. A hobbyist or a do-it-yourselfer might be inclined to use a soldering iron that plugs directly into the wall. For production purposes, you would need something with a power supply. So the soldering iron is what provides the heat to the metals being soldered, and the soldering tip is actually what is delivering the heat to the metals. The soldering tip is very important. Think of a soldering tip as a reservoir. The bigger the reservoir, the more heat you have to transfer. Also, the heat transfer is dependent on the surface contact area between the tip and the metal parts being soldered. So you want to increase that surface contact area as much as possible, and the shape of the tips allow for that surface contact increase. If you can see the tips here, these are simple tips, no heating element, no heating sensors in the tips, as opposed to this tip with a heating element and a temperature sensor in there that allows the power supply to regulate the heat and keep the temperature as stable as possible. Here you have a bevel-shaped tip, which is basically a cone-shaped tip sliced at the end to give you a greater surface area. Here you have a chiseled tip similar to a flathead screwdriver, and here you have a cone-shaped tip for small metal areas that you want to solder. You don't want the tip to go over the metal area onto the substrate because you'll damage the substrate. So the tips are very important, and we need to keep the tips in tip-top shape. Excuse the pun. But here are some things that are used in maintaining the tip in the best performance quality. One is the sponge, and when you wet the sponge, you don't want to over wet it. You don't want water to be dripping out of there. It should only be damp. Here is a brass cleaning agent. This is actually better than the sponge because it does not cause thermal shocking, which causes cracks on the tips and reduces the tip life. And if you have a really dirty tip and it's very hard to clean with either a sponge or a brass cleaning agent, this is a tip tinner that'll chemically clean the tip. Now, this is a brief overview of soldering. For any questions that you may have, feel free to call me or any of my associates at tequipment.net.